Right now, directly above your head, moving at 17,000 miles per hour, there are more than 34,000 pieces of debris, broken satellites, fragments of rockets, chunks of metal from collisions that happened decades ago, some the size of a bullet, some the size of a softball, some the size of a bus, and every single piece is moving at 17,000 miles per hour. At that speed, a paint fleck hits with the force of a bowling ball dropped from a skyscraper. A piece the size of your phone can destroy a satellite, and we have 9,000 active satellites up there, running your GPS, your weather forecasts, your credit card transactions, your TV, your internet, the military's missile warning systems, all vulnerable. And here's the terrifying part. If just one of those pieces of debris hits just one satellite, it creates thousands of new pieces of debris, which hit other satellites, which create more debris, which hit more satellites. And once that chain reaction starts, it doesn't stop. Within years, low Earth orbit becomes so filled with debris that launching anything into space becomes impossible. We'd be trapped on Earth forever. No more GPS satellites, no more weather satellites, no more communication satellite, no missions to the moon, no missions to Mars. Humanity confined to one planet by a cloud of our own trash. In 1978, a NASA scientist named Donald Kessler wrote a paper warning that this could happen. It's called Kessler Syndrome, and 46 years later, we're watching it start. The question isn't whether it'll happen, the question is how soon, and whether we'll see it coming in time to stop it. October 4th, 1957. The Soviet Union launched Sputnik, the first artificial satellite about the size of a beach ball, weighing 183 pounds, and in America, it triggered panic. The space race had begun. Over the next 67 years, humanity launched more than 16,000 satellites, the United States alone, more than 7,000. But here's the thing. In the early days of the space age, nobody thought about what happened to things after their mission was over. You'd launch a satellite, the rocket would have multiple stages. The first stage falls back to Earth, so burns up or crashes into the ocean. But the second and third stages, they reach orbital velocity, and then they're just left there. Same thing with satellites. Mission's over, battery dies, you lose communication, you just leave it. It stays in orbit for decades, sometimes centuries, and so over 67 years, we've built up a junkyard in space. Right now, the US military tracks 34,000 pieces of debris larger than 10 centimeters. That's about the size of a softball. But there are an estimated 1 million pieces between 1 and 10 centimeters, the size of a marble to a baseball, too small to track, but big enough to destroy a satellite. And 100 million pieces smaller than 1 centimeter, paint flecks, metal shards, still moving at 17,000 miles per hour, still dangerous enough to crack the windows of the International Space Station. And here's what should terrify you. In just the last 20 years, the amount of debris in orbit has doubled. Why? 2 reasons. 1 mega constellations. SpaceX's Starlink is planning to launch 6,000 satellites. OneWeb, Amazon's Project Kuiper. Combined, these companies want to put 50,000 new satellites in orbit and 2 collisions, because it's already starting to happen. People think space is big, and it is, but the useful parts of space low Earth orbit, where most satellites are, that's actually a pretty thin shell, 400 to 2,000 kilometers altitude, and we're filling it with junk. Every launch adds debris, every satellite that dies becomes debris, and every collision creates exponentially more debris. We're at a tipping point. A tipping point. So let's talk about what happens when 2 objects collide at 17,000 miles per hour. Imagine 2 satellites, each one about the size of a car, each one weighing about a ton. They're in different orbits, moving in opposite directions, which means they're approaching each other at 35,000 miles per hour. When they collide, the energy released is equivalent to detonating 15 kilograms of TNT. The satellites don't just bounce off each other, they shatter into thousands of pieces. A typical collision between two 1-ton satellites creates about 2,000 pieces larger than 10 centimeters, about 20 to 50,000 pieces between 1 and 10 centimeters, and millions of pieces smaller than 1 centimeter. And here's the critical part. Every single one of those fragments is now moving at orbital velocity of 17,000 miles per hour. The debris cloud spreads out, but because of orbital mechanics, most of the debris stays in roughly the same orbital plane, like a disk of spinning razors. And if there are other satellites in or near that orbital plane, the probability of another collision goes up dramatically. So one collision creates debris that causes a second collision, which creates debris that causes a third, which causes a fourth, and on and on. This is what Donald Kessler calculated in 1978. He wrote, "The debris flux from random mutual collisions of cataloged objects will exceed the natural flux from meteorites when the number of cataloged objects exceeds a critical density." Translation: once you have enough junk in orbit, collisions start happening on their own, even if we stop launching anything. And the question Kessler tried to answer was, have we already crossed that threshold? In 1978, his answer was, not yet. Today we have 10 times as many objects in orbit. And we've already seen the cascade begin, because in 2009 it happened. For the first time in history, like 2 satellites collided by accident. February 10th, 2009, 789 kilometers above Siberia, an American communication satellite called Iridium-33 was providing satellite phone service to customers around the world. It was operational, active, worth $50 million, and heading straight toward it at 17,000 miles per hour was a defunct Russian satellite called Cosmos 2251. Dead since 1995. No power, no maneuvering capability, just tumbling through space. Both satellites were tracked by the US Space Surveillance Network. Both trajectories were known, but collision probability calculations have large error bars, and the probability of a collision was calculated to be low enough that no alert was issued. At 11:55 a.m. Eastern Time, they collided. The impact released energy equivalent to about 14 kilograms of TNT. Both satellites were completely destroyed. The collision created at least 2,300 pieces of debris large enough to track, and an estimated 100,000 smaller pieces too small to track. That debris spread out across multiple orbital altitudes, from 500 to 1,300 kilometers altitude, and most of it will stay in orbit for decades, some pieces centuries. The International Space Station orbits at 400 kilometers. Some of that Iridium-Cosmos debris passes within tens of kilometers of the ISS multiple times a year. Since 2009, the ISS has had to perform dozens of emergency maneuvers to avoid debris from this one collision. The 2009 Iridium-Cosmos collision was a wake-up call. It proved that Kessler's scenario wasn't theoretical, it's real, it's happening. And the debris from that single event has increased collision risk for everyone. Every satellite operator now has to track thousands of additional fragments forever. But to understand how bad this could get, we need to go back to 2007. January 11, 2007, Xichang Satellite Launch Center, China. The Chinese military launched a ballistic missile called the SC-19, an anti-satellite weapon. The target, one of China's own weather satellites, Fengyun 1C, orbiting at 865 kilometers altitude. It had been dead since 2002, no longer sending data, just orbiting. China wanted to prove they could destroy a satellite in orbit, the kind of capability the US and Soviet Union had tested in the 1980s and then mostly stopped using because they realized how dangerous it was. The missile hit the satellite, direct impact. It's at 865 kilometers altitude. The impact created the largest debris cloud in history. Within hours, tracking stations detected hundreds of new pieces. Within days, thousands. Final count: at least 3,500 trackable pieces larger than 10 centimeters, and an estimated 150,000 smaller fragments. That's more debris than all previous accidental collisions combined. From one test, the international community was furious. According to NASA, the 2007 Chinese AS-8 test increased the overall collision risk for all satellites in low Earth orbit by 10 to 40%. And those 3,500 pieces, most of them will stay in orbit for 50 to 100 years, some for centuries. And then, in 2021, Russia did the same thing. They destroyed one of their own satellites, Cosmos 1408, at 485 kilometers altitude, less than 100 kilometers from the International Space Station. And now we all have to deal with it forever. Forever. Because at those altitudes, there's almost no atmosphere to slow things down. Debris doesn't fall, it just stays. So what happens when all this debris starts hitting satellites we actually need? Let's talk about what happens to you if Kessler Syndrome reaches the cascade phase. Right now, there are 9,000 active satellites in orbit. About 5,000 of them are American, 31 of those are GPS satellites. Every time you open a map on your phone, every time you use navigation, you're connecting to at least 4 of those satellites, but GPS does more than help you find the nearest Starbucks. Your bank uses GPS timestamps to synchronize transactions across millions of computers. Without that synchronization, the entire financial system breaks down. The electrical grid uses GPS for timing. Power plants across the country need to stay synchronized to 60 cycles per second. Lose GPS, and parts of the grid start failing. Cell phone towers use GPS for timing and location services. No GPS means degraded or no cell service. Modern farming relies on GPS-guided tractors for planting and harvesting. Lose GPS, and food production becomes less efficient, more expensive. Commercial airplanes use GPS for navigation. They have backup systems, but those are slower, less accurate. Airports would have to reduce flight capacity, delays, cancellations, and that's just GPS. We have weather satellites that track hurricanes. They give us days of warning before a major storm hits. Without them, we'd be blind. We have communication satellites that provide phone and internet service to remote areas, ships at sea, planes in flight, military operations. We have satellites that monitor ice caps, deforestation, pollution. All of climate science depends on satellite data. All told, satellites are responsible for an estimated $1.6 trillion of economic activity per year. Now imagine Kessler Syndrome reaches the cascade phase. Collisions start happening monthly, then weekly. Satellite operators start losing satellites faster than they can replace them. The International Space Station would have to be abandoned. The Hubble Space Telescope could never be serviced again. No moon missions, no Mars missions. The James Webb Space Telescope is safe. It's 1.5 million kilometers away, but we'd be cut off from space entirely. When I wrote the original paper in 1978, I was trying to warn people that this could happen. Not that it would happen, but that it could. And the solution seemed obvious: don't create debris. But here we are, 46 years later, and we've created more debris than I ever imagined. The question now isn't whether we'll hit the cascade threshold, it's whether we're already past it. So, can we fix this? Can we send up spacecraft to clean up the debris? Here's the problem. There are 34,000 pieces of debris larger than 10 centimeters that we can track. Let's say we build a spacecraft that can capture and deorbit one piece of debris per week. At that rate, it would take 650 years to clean up the debris we have right now. And meanwhile, new debris is being created every time there's a launch or a collision. And the cost. Each debris removal mission would cost tens to hundreds of millions of dollars. To clean up all 34,000 pieces would cost trillions. And who pays for it? China created 3,500 pieces in 2007. Russia created 1,500 in 2021. The US has companies launching thousands of satellites. There are some technologies in development: harpoons to capture debris, nets to snag dead satellites, robotic arms to grab and deorbit objects, even laser brooms, ground-based lasers that would heat one side of debris, causing it to slow down and re-enter. Some of these have been tested. The European Space Agency is planning a mission called Clear Space 1 to capture and deorbit a spent rocket body, scheduled for 2026. One object against 34,000. The better solution, according to most experts, is to stop creating new debris. There's already an international guideline that says satellites should deorbit themselves within 25 years of their mission ending, but it's voluntary. There's no enforcement. SpaceX's Starlink satellites are designed to deorbit within 5 years. They orbit low enough that atmospheric drag will bring them down naturally. But the thousands of older satellites don't have that capability. They just stay up there, dead, waiting to collide with something. And anti-satellite weapon testing has to stop. In April 2022, the United States announced it would no longer conduct destructive anti-satellite missile tests, but China and Russia haven't made the same commitment. The Outer Space Treaty from 1967 doesn't address debris. There's no binding international law that prevents nations from creating debris. So here's where we are. We have 34,000 pieces of debris in orbit. The collision risk is going up every year. Cleanup is technologically possible, but economically and politically impractical, which means the only real solution is prevention. Stop launching junk, design satellites to deorbit, stop blowing things up in orbit, and are we doing that? Last year, we launched more satellites than any year in history. SpaceX alone plans to launch 12,000 to 42,000 Starlink satellites over the next decade. Space is getting crowded, and we're not slowing down. The Kessler Syndrome isn't a binary thing. It's not like one day we're fine and the next day we're trapped on Earth. It's a gradual process. Collisions become more frequent, insurance rates go up, certain orbits become too risky, and eventually we reach a point where space becomes economically unviable. We're not there yet, but we're heading in that direction. And if we don't change course soon, we will get there. We will get there. For 67 years, humanity has been a spacefaring civilization. Satellites have transformed communication, navigation and weather forecasting, science, national security, but we've treated space like an infinite junkyard. Right now, above your head, 34,000 pieces of debris are orbiting at 17,000 miles per hour, each one a potential trigger for the collision that starts the cascade. We still have time, but the window is closing.